Merci, Étienne. Alors, c'est un plaisir de vous présenter le professeur Adolfo GARCIA de l'Université de San Andrés en Argentine et qui participe, est directeur du Centre de Cognitive Neuroscience de là-bas. Il participe aussi à des recherches avec l'Université de Californie à San Francisco et je pense l'Université d'État du Chili. Ce qui est remarquable dans sa présentation, vous allez le voir, c'est la multidisciplinarité qui est présente dans ses recherches. Et ceci se retrouve directement dans la problématique qu'il va nous présenter aujourd'hui. Euh, Moi, j'ai connu Adolfo par l'écoute de certaines conférences où il s'intéressait au grounding des symboles, problématiques que vous connaissez bien dans notre milieu. Euh, il reprend cette problématique-là et montre que pour que le sens apparaisse, le meaning, le sense soit fait, le sense meaning soit fait, il faut en appeler à plusieurs dimensions, à plusieurs aspects pour comprendre, expliquer et fonder la signification dans les symboles. Et c'est là sa richesse et son expertise. On touche les dimensions linguistiques, les dimensions sémiotiques, les dimensions neuroscientifiques, etc. Et ceci croisé avec des problématiques et des expérimentations informatiques. Alors, ce qu'il va nous présenter aujourd'hui est des propositions, des réflexions sur le problème d'intégrer ces différentes dimensions à l'intérieur d'une vue synthétique de la problématique du sense-making. It's a pleasure for me to present Adolfo GARCIA from the University of Santa Andrés in Argentina. He's director of the Cognitive Neuroscience Center at this university. And he collaborates, as far as I know, to certain universities, mainly the University of California in San Francisco, and the linguistic and humanities centers at the State University in Chile. I have met indirectly by seminars during the last years the work of Adolfo GARCIA through his interest in the problem of grounding the symbols he sees as semiotic artifacts. And his research question is, what is the sense making? How do we ground it? And his main contribution is to show that it has, the explanation of this problem has to be grounded in many dimensions, be they in neuroscience, social embedment, has be language, psychology, and even philosophy. You cannot integrate this problem just very easily. And it's just, I believe it's the topic he's going to be presenting today. It's the problem of integrating how sense-making comes and calling upon many disciplines. So it's your turn now, Adolfo, to present your topic. Thank you very much.
Thank you very much. Merci bien, merci beaucoup. Je suis tenté d'essayer de faire cette présentation-ci en français, mais je suis pas sûr que j'aurai la clarité de tête de trouver tous les mots corrects. Alors, si vous êtes d'accord, je crois que je vais changer à l'anglais. And I'm going to continue this in English for the benefit of everybody. Thank you very much. It's a real pleasure to have the opportunity to share the work that we are doing with our teams and that we've been doing for the past 10 years now around the notion of grounded cognition, which is one of the main topics and shared concerns in this seminar series. And I want to share with you some of the work that we've been doing in an attempt to expand beyond the typical foci of this line of research. In neuroscience, at least, grounded cognition research has been dominated by behavioral and brain activation studies, rather than, for example, functional connectivity approaches. The focus has been mainly on action semantics, to the detriment of other categories, including, for example, the study of face-related language or negation or social concepts. The focus has also been on healthy individuals, often underexploiting the wealth of information that can be extracted from people with different brain disorders. Often using highly artificial materials, typically single word or single sentence paradigms where stimuli are presented in a fully decontextualized fashion. And this deviates quite substantially from the way in which semiotic and more precisely linguistic prompts, cues, information, stimuli appear in our daily dealings with the environment, and more particularly with the world of language. It's very rarely that we stumble upon isolated words as opposed to full-blown cohesive and coherent texts. And finally, in terms of data analysis, the field has mainly favored inferential statistical approaches, which are fantastic and tremendously useful for many things, but much less work has been done exploiting more recent approaches rooted in artificial intelligence and machine learning. So this overarching view of these traits, if you want, of the field have shaped the research program that we've undertaken. And basically, you could say that most of the things that I'll be sharing with you today emerge from a strategic and very deliberate reaction to these features. Basically, I'd like to tell you today a little bit about the framework within which we operate. Then we're going to take a deep dive into action semantics. Then we're going to be tackling other domains that go beyond grounded in the primary sensorimotor systems. I'll be sharing with you then some findings from our first excursions into the world of social semantics. And finally, I'll share with you some of the new translational efforts that we've been working on, and I'll have some concluding words before we leave the floor open for questions and answers. That being said, if at any point during my talk you want to raise a question, make a comment, engage in dialogue, please do not refrain from doing so. I'll be more than happy to be interrupted. And it will be a very good outcome of this talk if I didn't get to go through all the slides, because a very interesting conversation ensued at some point. So please feel free to interrupt me at any point. Let's start by looking at the overall framework. This will not come as new information to any of you, I presume, but if you think about language in particular and the way in which many mainstream psycholinguistic and neurolinguistic theories describe language, all you need for those theories to be workable, to be plausible, is a head. And that's it. The mechanisms, the systems, sometimes the modules, depending on the theoretical flavor that the theory proposes, they presume a brain, and there's no other sort of organismic constraint to how that brain is shaped, organized, how it evolved, and how it deploys its functions daily. Now, you can think about language in those terms, and that's perfectly okay, but you can also think about the relationship between language and the brain as something that happens in the context of a body. So our language is not so much embrained as it is embodied, and that body also is not floating in a contextual vacuum. The idea is that just as our body is the overall organismic context within which the brain resides, so is our material, physical, social, cultural milieu, a never-ending source of constraints for the way in which the mapping between language, brain, and body is deployed in daily life. And the other interesting thing about language is that it's sort of a catalyst. You can think of it as a vortex that is shaped, sculpted, molded by the influence of many, many, many dimensions of interest, including genes, brain, our perception and action skills, memory, our overall experience, our affect, socio-affective, socio-emotional functions that we are capable of deploying, and the overarching personal, physical, social, and historical context. So language, in a way, is the one thing that brings all of these strands of organismic influences together, cutting across social and biological dimensions. And of course, this is not something that I propose to be exclusive to language, but it is one of the distinct aspects of language. In a way, when you think about language in these terms, and you accept that language is one of the main sense-making semiotics that we've developed as a species, then it is incumbent on us to try to map sense-making across the human organism, trying to track the convergences of the neurological, cognitive, sensorimotor, visceral, perceptual, and social processes that jointly shape our semiotic experiences, as we've postulated in this book that was published just 2 months ago. And how do you do this? Well, one of the things that you need to make this happen is to have a very wide and varied toolkit. So the research I'm going to be sharing with you today will be leveraging to different extents classical behavioral paradigms in which key presses are required in the face of semi-contextualized stimuli. Also, I'm going to be sharing some insights coming from naturalistic text processing. I'll be telling you a little bit more about that quite soon. We've also developed some more full body immersion paradigms involving exergaming. So the full involvement of your body in a motivational task that involves language, as we will see. And of course, in line with more recent trends, automated speech and language analysis. So we are leveraging natural language processing tools and automated audio signal processing tools to try to capture some aspects that are even of interest to this line of work beyond the typical constraints of traditional paradigms in the field, and combining this with machine learning approaches to data analysis.
Adolfo, can I interrupt with a question?
Of course you may.
As you were speaking, you used the word semiotic. This is a multidisciplinary community. Could you please say what you mean by semiotic?
Yes, I'm referring to semiotic as you can think about it disciplinarily as a field of inquiry that is concerned with the study of signs in the broadest possible sense, be they symbols or indexes or any type of stimuli within your body or outside of your body that has the potential to evoke meaning through a
The
process
trouble-
that is...
The trouble with that definition is the three of the terms you used are also not known to this community.
I
What do you
see.
mean by index, and what do you mean by symbol?
Let me, I understand. Let me make it simpler. Semiotics is concerned with the study of how meaning is created, triggered, associated with anything that surrounds you and anything that is inside you. So a table next to you could be a semiotic trigger, a word that you read, someone moving their hands, two children playing, smoke that you can see at a distance, the gut feelings that you have, your heart beating, any event to which you can ascribe meaning will be part of the scope of semiotics as a discipline. And many of the things that I say when I speak about semiotics, they come from a Peircean tradition. I'm thinking about Charles Sanders Peirce, who was one of the, I should say, the main advocate of this conception of science and meaning.
One last question. I'm so sorry, I don't want to be a sadist, but you brought it all down to meaning. Well, I cannot stop myself from asking you what you mean by that.
That is a very interesting and complicated question. It reminds me of what Saint Augustine said when he was asked about time. Time, I know exactly what it is, unless you ask me to define what it is, right? By meaning here, my own conception of meaning is the phenomenological experiences we have in response or in anticipation to the things that happen within us and around us. Meaning is not just the concepts that are evoked by words or by numbers or by feelings, but meaning is the entirety of the imagery, the sensations, the feelings, the imaginations, the prospections, the memories that are evoked by the things you see, touch, feel, smell, hear, perceive, or otherwise conjure up in your head.
Gracias, he terminado. Habla.
Thank you. So should I carry on now?
Yes, please.
Thank you for those questions. And I'll be happy to double click on any of these concepts that I shared with you. There's also the biological side of things. So we combine all these tools that I just mentioned with electroencephalographic recordings. You can see that on the top left corner of the screen. That's my wife, by the way, who used to be my go-to guinea pig when it came to piloting experiments. We also use magnetic resonance imaging, both structural and functional. We've also used magnetoencephalography to have data that are both spatially and temporally precise in terms of brain coordinates. We've also had a chance to work with intracranial recordings, that is, implanting electrodes directly within the brain to capture as pure a brain signal as you can with current technologies. And we've also used non-invasive brain stimulation techniques. And all of this I'm going to be sharing a little bit of with you as we move on. So that's the toolkit. And with this, one of the things that we've been doing over the past few years is to take a deep dive into action semantics. When I say action semantics, I'm referring to the whole collection of concepts, if you will, that evoke or denote or imply bodily motion. In the domain of language, words such as jump, run, grab, clap, applaud, throw, they all denote movements of your body. That is the main manifestation of action semantics. And of course, you can have manifestations of action semantics triggered by language-less pictures, movies, sounds. But here we're going to be focusing mainly on language. And one of the things that has been, I dare use the verb shown, proven here, is that you can think about the organization of semantic information in your brain, at least in terms of two big collections of systems. On the one hand, you have modality-specific networks, such that, for instance, when you hear the word kick, you will have a distinct pattern of activation in the same brain circuitry that allows you to actually execute a kick with your legs. So that is what we call modality-specific systems, or embodied systems, if you will. But at the same time, there are regions and networks in your brain which sort of bring together streams of information from all of these specific modalities. So information that pertains to action, and information that pertains to the color of an object, and to the smell of that object, and to the touch of that object, and so on and so forth. All of those patterns of information converge into multimodal conceptual systems. So this is pretty much accepted by, I should say, the vast majority of linguists and neurosemanticians nowadays. But one question that remains is the one that I'm gonna focus on just in a few seconds. But here's just to give you a sampler of what I mean, right? So when you are dancing, that depends on the concerted activation of a collection of regions and networks that you can call the action system, or brain action networks, spanning regions in the primary motor cortex, the supplementary motor cortex, the basal ganglia, the cerebellum, and so on and so forth. And then when you listen to words that allude to bodily motion, you can see that these regions are distinctly engaged. Not only that, some studies have suggested that when you listen to a word that evokes a manual movement or a leg movement, you can see distinct patterns of activation in the portions of the motor networks that are responsible for your movements of your hand or your movements of your legs. Now, we have done a number of contributions, made a number of contributions here. And here's one of the main questions that are still hotly debated in the field. So, okay, there are these two systems, but what about the timing of those systems? When you are processing language, what is the time course of meaning in your brain? Do you first activate these conceptual systems that bring together information from different streams, and only then do you activate the modality-specific systems? There are certain theoretical accounts that propose that this is exactly the case, and that the engagement of embodied systems would be epiphenomenal, sort of a percolation, something that happens after the real conceptual or semantic processing has happened in these multimodal conceptual systems. On the other hand, you have evidence that suggests that, hey, embodied systems can be engaged quite quickly upon perceiving a word or an image. So how do you settle this debate? We've done some studies that aim to tackle this question. So here we used magnetoencephalography. This technique, it's a neuroscientific technique that's not widely available. It's very costly, but it's very, very unique in the sense that it gives you both very good spatial resolution. It allows you to know exactly which brain region is participating in a given process, but it also gives you very good temporal resolution. You can see the modulations in those regions at the level of milliseconds. So what we did here was we presented participants with action words such as jump, run, kick, and then abstract verbs such as imagine, dream, desire. And we looked at the activation in two regions of interest. First, the primary motor cortex, which is the main hub for moving your body, if you want to call it that. And then the anterior temporal lobe, which is the main region engaged in multimodal conceptual processing. And what we observed was that this is the time that it takes the primary motor cortex to discriminate between action verbs and abstract verbs. In roughly 120, 150 milliseconds after you see a word, you have discriminatory activity in your primary motor cortex. However, the anterior temporal lobe only significantly discriminates between both conditions much later, in the order of 400 milliseconds. And we've also corroborated this with machine learning analysis, showing that the peaks of classification between individual action verbs and individual abstract verbs was reached between 100 and 150 milliseconds in the primary motor cortex, but much later in the anterior temporal lobe. So this suggests that when you are faced with words, at least with action-related words, your brain first reactivates the modality-specific meanings or events that are being described, and only later do you have more complex multimodal conceptual processing going on. The other question that we've tackled is the following. In a study like the one I just showed you, we are presenting these words pretty much in isolation. So you're seeing actual words trapped in their own cage. And then you're seeing abstract words trapped in their own cage. And then there are studies about emotion words in their own cage and things like that. So psycholinguistics and neurolinguistics have accustomed us to thinking about language as a zoology, as a zoo of categories, where every category is neatly trapped in its own cage. But the truth is that language is not so much about traversing a zoo as it is about traversing, sort of being part of a safari, where all these words are constantly interacting, coexisting, overlapping in non-discrete ways. So one of the things that we are interested in is assessing to what extent those embodied phenomena, those grounded phenomena that you observe when you have isolated items remain significant when you actually start seeing those words in the context of naturalistic texts. So we've created texts like this. This is not a text that's gonna earn a Pulitzer Prize, but it's a text. It's a short story which is fully cohesive and coherent, with unfolding semantic relations, with co-reference, with all the things that make a text, if you will. And we have comprehension questionnaires. And we ask questions about information that is coded in the verbs and information about circumstantial aspects of the stories. We have an action text, and then we have non-action text. In the action texts, the focus is placed on how the protagonists move. So the story is about people who run, who jump, who dance together, who play soccer. There's a lot of movement. And then we have non-action texts in which the protagonists are static. And the story is about what they imagine, what they observe, what they feel, what they fear, but no movements are described. Now, when you read these texts, they are quite natural, if you will. But what participants don't know is that they have been very carefully constructed so that they are matched along many, many, many variables. So we've really controlled these texts so that the only thing that they differ in is the action, non-action axis, if you will. And with these texts, we found a number of things. In this study, for example, we had 3 groups of participants. To the first group, we applied a nodal transcranial direct current stimulation over the primary motor cortex. Let me put it differently. We hyperactivated their primary motor cortex. And then we had another group to which we applied sham stimulation, placebo stimulation, if you will. We basically did nothing. And then we had another group in which we applied stimulation in another brain area, the ventrolateral prefrontal cortex, ventromedial prefrontal cortex, sorry, which is not involved in physical movement. And what we found is that, and we gave them the action text and the non-action text, and we asked them questions about the verbs and the circumstances. We found that when you hyperactivate the primary motor cortex, there's a selective reduction in your comprehension of action meanings. You hyperactivate your primary motor cortex, and you comprehend actions in naturalistic texts worse than you comprehend other types of processes and circumstances. Such a difference is not found when you apply placebo stimulation. And that difference is not found when you stimulate a control area that's not involved in physical movement. So this suggests that there's a direct link between the functionality of your primary motor cortex and specifically the comprehension of action-related meanings, even in naturalistic texts. So this is a step forward towards having more ecologically valid approaches to grounded cognition. We've shown similar things with patients with frontal lobe epilepsy, compromise of frontal and motor systems, with no compromise of posterior, including multimodal conceptual systems. And we found that in those patients, you have selective deficits in comprehending actions in naturalistic texts. And those deficits correlate with the degree of structural and functional compromise of their motor networks. And not only that, when you consider those data, you can actually have quite good level of classification using machine learning algorithms to discriminate between patients who have frontal damage and patients who have posterior damage. So we can actually, just by looking at their performance in comprehending texts, how well they comprehend action information and non-action information, and their brain correlates, we can identify whether a person has frontal damage or not with over 85% accuracy. We've also shown that there is a genetic basis for the connection between action meanings and motor systems. We had the chance to study this individual with a very rare form of ataxia. This is a movement disorder that's caused by a genetic mutation. And we found that this person, he was in a wheelchair, he could not move at all. First of all, he had a selective deficit in processing action-related verbs. There were no significant differences compared to controls when it came to action verbs or manipulable nouns or abstract nouns. The deficit was selective for action verbs. This correlated with the atrophy of the cerebellum, which is another brain region that is critical for actual physical movement. And the interesting thing here is that we map the areas of the brain in which the gene that was mutated in this patient typically expresses. And we found that the areas of expression of that gene overlap with the patient's areas of atrophy with more than 62%. So this is the first indication that this particular gene, STUB1, STUB1, may be one of the genetic determinants of the linkage between motor systems in your brain and action semantics. There are many more things that I could tell you about this line of work, but I'm mindful of everyone's time. I just want to say that the link between action semantics and your body goes beyond your brain. And when you listen to action verbs, even if you don't want to, your muscles become active. Even if you're just trying to keep your hand still, the very perception of an action verb will lead you to unconsciously exert more pressure on a sensor, on a grip force sensor. We've shown, for example,
Adolfo, I just you must know that Victor Frack is here at UCAM.
Oh, is he there physically now?
He's not present. No, I sent him a message that he should come now, but he'll watch it on the tape.
Victor, he's a very good friend, and he's the author of this very exciting work, which, by the way, it's not the only one. His group has published several other papers with the grip force sensor, and it's just a fantastic device to illuminate the links between brain and body. So thank you for pointing that out. I hope you're listening to this, Victor. Looking forward to talking to you soon. We've shown that when you are writing words, if the words that you are writing denote movements of your hands move differently when you are writing, for instance. We've also found electrophysiological correlates of the integration of action meanings and manual movements. I don't want to bore you with the details because I want to show you other things. We have full-blown theoretical models to account for these dynamics. And we've also shown that this extends onto more naturalistic settings. In this study, we asked healthy individuals to listen to the action text and to the non-action text. And they completed the comprehension questionnaire. They did quite similarly. They comprehended both texts quite similarly. And then we split them into two groups. One of the groups did an exergaming protocol. They spent 5 days playing Nintendo Wii games, moving their whole bodies, jumping, dancing, kicking, throwing things for 60 minutes a day. And the other group played static video games, the typical video games in which you don't move your body, you just press buttons. And after that, we gave them another action text and another non-action text. And all of this was complemented with EEG recordings. We found this. The fact that you spent 5 days systematically moving your body caused a selective reduction in your capacity to comprehend action verbs in the naturalistic texts, selectively for action information. And also, that decrement was significantly correlated with the decoupling of motor sensitive brain mechanisms captured by functional connectivity. So this is very interesting to see that those early intuitions that we had between the relationship between your neural motor systems, your body, and action semantics, they hold even when you're dealing with naturalistic texts, and even when you interpolate ecological body movements, such as the ones that you would normally do in your house, in this case, by playing action video games, whole body immersion video games. I could tell you more about this line of work, but I would like to move on to other things. Something that's very interesting is this, is that when you realize...
Before moving on, one little report. Victor is not here, but his doctoral student, David Labrac, just joined us as well. So you have a representation.
Fantastic. Thanks for that. Very nice to meet you virtually. And it'll be great to have a chance to talk afterwards. Something I want to mention here is that there are clinical translational implications of this line of work. Once you understand that action-related words in texts or in isolation, their processing depends on these motor systems, you can come up with this question. Okay, so maybe I can use those words to see if motor systems are working correctly or not. And this idea led to a clinical research line by which we are trying to use action verbs as a window to detect movement disorders. So we've shown, for instance, that persons with Parkinson's disease, which is the most prevalent movement disorder worldwide, they have selective difficulties in processing action verbs, and that is associated to abnormal connectivity of motor networks in the brain. We've shown this in different tasks, including picture naming. We've shown this using naturalistic texts. Parkinson's disease patients, when they are cognitively okay, they have selective deficits in understanding action-related information in naturalistic stories. We found this in spontaneous discourse. You ask people to tell you what their typical day is like, and then you run NLP algorithms that allow you to capture the weight of action and non-action semantic fields, and you can find that the semantic fields that are most discriminatory between people with Parkinson's disease and without Parkinson's disease are action-related semantic fields: walk, work, take, make, get, gain, play. We have a more sophisticated rendition of that in this study, but I will not go into the details. And we've shown that just by looking at the weight of action semantic fields in your spontaneous discourse, you can classify between persons with and without Parkinson's disease with anywhere from 80 to 90% accuracy. So this is very interesting to find this clinical application of this line of work. In a nutshell here, motor system grounding during action concept processing is primary rather than epiphenomenal. It is significant in naturalistic texts. It is supported by relevant regions, networks, EEG patterns, and genetic foundations. It is pervasive across the peripheral motor system, even. It's influenced by both physical and linguistic experience. I skipped the study where we showed the linguistic experience bit, but trust me. And it can be selectively compromised by movement disorders. There are two other things that I want to mention, and I'll try to be as quick as I can. Grounding of semantics in the human brain is not just something that pertains to action-related meanings. There's previous evidence showing that just as you have systems in your brain that are specifically responsive to olfactory stimuli, when you smell a cheese, for instance, and then you read words that have olfactory connotations, such as cinnamon, those words distinctly engage the olfactory region of your brain. Words that evoke smells engage your olfactory regions distinctly. The same has been observed for words that evoke flavors and taste-related systems in your brain. And the same has been shown for words that evoke sounds such as bell, phone, alarm, sirens, and your primary auditory cortex. So grounding is not something that only befalls upon the widely studied phenomena of action concepts. But we've gone beyond these primary sensory motor systems. And we've produced the very first evidence that, for example, when you are processing face-related words, you have distinct activation of your face processing networks. We did this with two experiments. The first one with healthy participants in a typical EEG study, and the second one with two patients who were undergoing pre-surgical treatment with intracranial electrodes. And these patients, they had electrodes implanted directly within face processing networks, the very networks that allow you to identify faces when you are moving around in daily life. And we asked participants to do a very simple task in which they were presented with words, and they had to press a key to say whether the word was face-related or not. That was it. What we found was a number of things. We found that face-related words modulated distinctly the N170 component. This component is the earliest indication of processing of facial information when you are looking at actual faces. So this is the first demonstration that face-related words modulate the same electrophysiological mechanisms that respond to actual face recognition. We found that within the right fusiform gyrus, which is the main hub in your brain for processing actual faces, the face-related words created massive bursts of activation very early and much earlier than electrodes implanted in multimodal conceptual regions. And we also found that there were different connectivity patterns between these mechanisms. I'm going to skip the details here. But we also, so this shows that grounding also happens with very complex stimuli and with brain regions that are beyond primary sensory systems and primary motor systems. But this also happens for abstract linguistic units, such as negation markers, the word no, or the operator don't. We've shown that when you're typing words on a keyboard, if I give you a word in a positive context, such as now you will sign the contract, and you have to type the word sign, versus now you won't sign the contract, and you have to type the word sign, you're typing the same word. The only thing that changes is the polarity of the operator. You have positive polarity or negative polarity. What happens is that when the word is negated, you type more slowly. This is quite interesting. Negation seems to be grounded in inhibitory mechanisms, in action suppression mechanisms. And in this paper, we took that idea to the extreme, and we assessed processing of negation in patients with behavioral variant frontotemporal dementia, one of whose core symptoms is inhibitory deficits. These patients have very, very, they manifest severe deficits in their capacity to inhibit. Their inhibitory system is disturbed. And we found that they had significant and selective alterations in their capacity to process negation as opposed to affirmative sentences. So this suggests that even abstract operators such as negation in language also follows grounding principles, here recruiting inhibitory systems mainly. So grounding phenomena can be found in the domain of face processing mechanisms for facial concepts across multiple dimensions and very quickly. And you can also find it in terms of inhibitory mechanisms for negation. And the very, very final thing is that I'm just going to say this very quickly so that we have some minutes to discuss. Now we are studying social concepts, concepts that evoke interpersonal relations. They could be nouns, verbs, adjectives that evoke affiliation with others, or rivalry, or cooperation, or anything that involves social dynamics. And I'm going to be very quick here. When you ask people with socio-affective deficits,
you don't have to be so. You don't have to be so quick. You've been interrupted several times, so you have much more time available to you. So
okay, I appreciate that. But I'll try to strike a balance. When you ask people with socio-affective deficits, for example, patients with behavioral variant frontotemporal dementia, who manifest loss of empathy, emotional dampening, and inadequate social interactions in daily life, and you give them texts with lots of social information and texts with no social information, they have selective deficits comprehending the social texts. This does not happen in Parkinson's disease, and this selective deficit does not happen in Alzheimer's disease. It's very specific to people who have this socio-affective disorder. And the interesting thing also is that that particular disorder correlates with anatomical, functional, and electrophysiological alteration of brain mechanisms involved in social cognition. We've also found that the cerebellum has been increasingly implicated in social cognition, in these interpersonal capacities that we have to interact with others. And so we asked ourselves, are linguistic social concepts grounded in the cerebellum as a critical social cognition hub? And in this study, we administered social text comprehension and non-social text comprehension tasks to patients with cerebellar ataxia, who have focal and massive compromise of the cerebellum. And we found that these patients, like the BBFDD patients, have selective deficits in grasping social information. They do not have deficits understanding non-social information in texts. And that in healthy people, you find that the greater the connection between the cerebellum and cortical regions implicated in social cognition, the better their comprehension of social text. But in the patients with cerebellar atrophy, there's no such association. That correlation has been abolished. So this is the first demonstration that social concepts are grounded in neural mechanisms that subserve your broad overall socio-interactive skills. I'm gonna skip this study. It's quite interesting. It's currently under review, but I wanna save the last minutes for something else. The bottom line of this story is that socio-cognitive grounding during social concept processing is significant in naturalistic texts, the two studies that I showed you. It can be selectively compromised in socio-behavioral disorders. It is linked to relevant anatomical, hemodynamic, and electrophysiological substrates. It is present beyond canonical cortical limbic systems, engaging the cerebellum as well. And it is associated with interpersonal experience. This is a study that I skipped, but I'll be happy to delve into it if you find it interesting. To conclude, especially thinking about these translational efforts, in all this research, we are finding that strategic linguistic tasks can be very useful to find markers of specific neurodegenerative diseases, Parkinson's disease, behavioral variant frontotemporal dementia, cerebellar ataxia. One of the things that we are doing is we created this network, the INCLUDE network, the International Network for Cross-Linguistic Research on Brain Health. We noticed that there are roughly 7,000 living languages in the world nowadays, but less than 20 have received any attention in the clinical literature using language. So to make matters worse, from that very restricted number of languages, most of the evidence, probably over 70% of the evidence, comes exclusively from English speakers. So this creates a massive gap in knowledge, because you cannot assume that whatever holds for the relationship between language and the brain, or their dysfunctions, in English speakers will be directly applicable to speakers of Spanish, Portuguese, Quebecois, Urdu, Chinese, whatever you might think. So we created this network, which currently holds over 40 sites spanning nearly 30 countries, to start doing cross-linguistic research and try to understand which of these markers are language-specific or cross-linguistically generalizable. The other thing that we did in this translational effort is we set up a company and we developed an app, which is called TEL, the Toolkit to Examine Lifelike Language. And this is a very simple web-based tool that allows examiners and patients to record themselves with different language tasks that we created, and it provides them with on-the-fly metrics, capturing relevant aspects of the linguistic behavior, so that we can actually turn all this knowledge that we are generating into a clinically usable tool. And we'll be leveraging this tool in this massive grant that we just obtained. It's my first NIH grant. It's going to be a massive effort with a budget of over $8 million to capture language markers of neurodegenerative diseases across 5 Latin American countries and the US, totaling a sample of nearly 2,700 participants. So we'll start working on this in the second half of this year, and we'll keep it going for 5 years. And we are very excited about the prospects of bringing these grounded cognition and neuro-linguistic notions into an actual clinical application that's applied in a widespread fashion across an underserved region such as Latin America. So everything that I showed today is, of course, the output of a very, very wide collection of people, mainly the members of our Cognitive Neuroscience Center at Universidad de San Andrés in Argentina. So my gratitude to all of them. And also our many, many national collaborators, our regional collaborators across Latin America, and our global collaborators around the world. So grounded aspects of meaning, and with this I conclude, may be more pervasive than we imagine. No dimension is irrelevant to make sense of sense making. And I hope that the data I shared with you today will inspire further work from you or from all of us collaboratively towards this end. Thank you very much for your attention.
Many thanks, Adolfo, and I'm sure Jean-Guy. Jean-Guy, do you want to turn on your camera or handling the questions?
I'll leave you handle the questions. You have the experience on that.
The questions can be in French or in English, and you can raise your hand with the electronic means, or here in the room you just have to raise your real hand. I can see you. I'm never at a loss, so to launch it, I'll ask a couple of things. One is, to what extent is the action semantics based on animate action as opposed to inanimate action? I'm sure you're asked this question a lot.
Could you define what you mean by animate and inanimate action?
You could do with a human or an animal body as opposed to a machine, etc.
The entirety of the research that we do is based on animate action. It's always stimuli that describe movements of the human body. And I should say that is also true for the vast majority of research out there. I can think of only a couple of experiments in which motion has been conveyed through non-human-like stimuli. But the short answer is the very vast majority of research comes from animate action along the lines in which you define the term.
So, for example, a volcano would not produce activity in motor areas.
That is a very good question. It depends on what it is that you are describing about the volcano. If it's just the word volcano, you would not expect any type of motor grounding. Now, there are studies that have shown that when you have non-literal linguistic constructions, metaphors, for example, or other forms of figurative language that indirectly allude to physical motion, even if the words themselves in their standard, if you want to call it that, semantic associations do not evoke meaning. When they are metaphorically used to convey action, you do have engagement of motor systems. So what I'm trying to say here is that if there were a context in which volcano or some aspects of the volcano were used metaphorically in a mutually intelligible way, such that the interlocutor would construe an action-related meaning out of that, then you might expect some sort of motor grounding.
Rushen, go ahead. Professor Rushen Shi, also from UCAM.
Hi, thank you for this interesting talk. I have two questions. Let me start with one. In your experiments, you were using action verbs. Did you? I assume it's related to your comment you just made. You must have done experiments when there's action words, but actually it's used in a non-action way. For example, the word hold or see or advance. You could say, I advance in the room. You could say, we have advanced the theory. So I'm wondering if you've done studies to actually see in those particular use in the context of non-actual action, non-observable action, like I see. I mean, even blind children will use the words I see, not to mean I actually see, but mean I understand. And what would you expect in your analysis in terms of brain responses?
Thank you for the question. We ourselves have not done any experiment with these usages, if you will, of these words. But there are studies that have looked at abstract transfer. For example, Professor Arthur Glenberg's group, who pioneered the action sentence coupling effect, the action sentence compatibility effect. They've shown, for instance, that when you have to move your hand forward, the speed at which you move your hand forward can be changed depending on the direction of the verb that you processed just before. So when you move your hand forward and you're processing a verb like push, which involves moving your hand forward, the speed of movement of your hand can be different than when you are moving your hand forward and you have a verb such as open the door, in which you go the other way around. That is concrete transfer. The same paradigm has been shown to show, has been tested with abstract transfer. So if you say something like, he wished him well, and the idea is that in a way you're sort of conveying that wish onto someone else, a forward response will also be accelerated, like what you have when you have a concrete action verb. So that is the most immediate evidence that I can think of that might be partly related to your question. But as to whether we've done anything in that direction, I have to say no, we haven't.
Could I invite David Labrec to address this question? Je ne sais pas si dans le labo de Victor, il y a aussi des données traitant cette question. David, mets ton micro.
No? Can I ask another related question then? Yeah, Stephen?
Yeah, sure. David, were you saying
David, est-ce que tu as quelque chose à dire? No?
Okay, go ahead, Ocean, sorry.
The other question is that you've been looking at these sensory modalities, how they're involved in the actual comprehension of language. I'm just wondering what you would expect if you have participants who have deficits in sensory modality. For example, people who are deaf, they must recruit brain differently. And I would assume you can predict different reactions in different parts of the brain as normals who have listening ability, who have listening and auditory and verbal abilities. The other question is with the age. There are children who are deaf from birth. They must have a different wiring of the brain. But there are adults who lost their hearing or who lost their sight later in life. Then their brain has been wired like normals. And do you have something to say about how you would predict reactions in the brain for these particular areas, like visual areas for movement, auditory areas for auditory verbs? And would you expect different responses? And how about for children who never had a wiring versus older people, adults who had wiring and lost that capacity?
I think that's a beautiful question, and those are beautiful questions. And I think that the second one, in a way, sort of captures one key element of my response to the former. The evidence, so the prediction would be exactly what you are proposing. I would predict that in people who sustained brain damage that compromised their olfactory system or the visual system or some other system, processing of linguistic material that evokes or the experiences related to those systems should be differentially impaired, much in the same way in which we are seeing selective action deficits in people with movement disorders. That being said, I do not know of any evidence beyond the motor domain when it comes to, let's say, the disruption of grounding mechanisms. But that would be my prediction. The second point you mentioned is critical, because what you do observe when you have people who are born deaf or who are born blind is that primary auditory areas in the first case and primary visual areas in the second case, they become repurposed. So you'll see, for example, in deaf individuals, that their primary auditory system becomes recruited early on to support visual processing. Or you see that in people who are born blind, their primary motor cortex becomes co-opted for processing auditory stimuli. So that is a critical point. And the final thing I would say is that usually when we do these studies with patients, we try to evaluate them in very early disease stages. Especially with neurodegeneration, the patterns of atrophy will progress through time. And if you give them sufficient time, and if they are not too old, and if they have good neuroprotective lifestyles, then you might expect compensatory mechanisms, plastic mechanisms, sort of affording new pathways for those units to be processed in a semi-normal way again. This is also conjectural. I do not know of any single longitudinal study on the disruption of grounding domains in patients, but the hypothesis would follow from the same principles that underlie your question, the way I understand it.
Yogi?
Thank you. Thank you.
Thank you very much, Adolfo, for this fascinating presentation on the multi-dimensions of sense meaning. I have so many questions and probably with no answers to be given. I would like to hear you in the understanding for myself of certain concepts you use. It's unusual to hear a linguist talk about sense meaning as you do. Usually, at least in the American semantics, the meaning is the reference. Here you're talking about the sense making. If I use a word kill, what I'm referring to is something's happening and the life is gone or whatever, the event. But if you're talking more in a Peircean sense or in a Fregean sense, you have the sense. That is something that's happening between the reference and the word itself. What I see in what you're saying is that we're making sense of something when there is a reaction, feeling, a motivation, a memory inside the individual, which is a completely different problem than what is the reference, what are the conditions of truth of the proposition. That for me is unusual. I share with that. It's the Peircean interpretant. You cannot go to the object, to the reference, without having that. But on the other sense, when you accept that thesis of yours, that words generate a sense that helps you to find the reference or determines the reference, you marry that to some action in the brain. If I used, and at least in French, probably in English also, we differentiate the sense of the word with the connotation. A word can have a lexical meaning and has certain semantic primitives that are present. If I say John killed Mary, afterwards he went with her and took a beer. You're making an English mistake there, not an ontological mistake. There's something in the word kill that is shared by the community, that the person that is using the word kill is dead or something like that. You don't understand what is going on if she goes and take a beer with her. On the other side, linguists will say, well, that's different from the connotation. The connotation will often have deep reactions at the level of emotions, of social acceptance, and so on. You probably heard the debate over the word with an N. Should we use it? The original word has a meaning, a sense, but it will stimulate many connotations. And this is the connotation will excite probably and naturally, and that's what you saw, certain parts of the brain, because the sexual vocabulary is like that. The certain organs, sexual organs have a word, they have a sense, and they refer to something, but they have a heavy connotation. So when you look at your brain results, are you showing that these words have a high connotation, or are you showing that they have a high sense, which is different as a problem? And when you come and say, well, I test that by the understanding, by the comprehension of a text, how do you relate this problem of understanding and problem of concept? Is it the fact that what comes to my own brain is that the definition of comprehensions is the ability to feel something, to react on your brain, but is it really a conceptual understanding, really a comprehension, or just the ability or the capacity when confronted to the word, you have a certain reaction, a connotation? If you talk to a Jewish person that had the experience of the Shoah, well, you just have to say the concentration camp. That word has a reference, that word has a sense in English language, but it has a heavy load of connotation, which will automatically probably excite the brain in a certain sense. So you see my difficulty is what you prove as existing in the brain, is it in fact showing the connotation that is associated to the word, or really its sense in the or the interpretant of Peirce, than the reference, or what in English we'll use the meaning.
Okay, now you have to pause for an answer.
Sorry about that question.
It's there's a sort of dialectical, or if you will, cross-disciplinary thing here, because I do not typically go back to the Fregean notions of sense and reference to think about these things. That was a very interesting proposal back in the day with the Morning Star and everything, but it's very limited. It accounts for only a very restricted subset of semantic phenomenon. What is the referent of anguish? What would be the referent of fear of incapacity of all these words that you might call abstract. So I do not typically think about reference as anything that is very useful towards a comprehensive understanding of lexical semantic mappings, just because it's just one province out of a much vaster territory. The second thing is that the thing with reference is that, of course, you cannot overlook the interpreter. Basically, if you were able to remove the interpreter, then the concentration camp or a box or a rock would mean what they mean. But the truth is that things mean to people, and the meanings that you ascribe to things vary widely among people, like you very well pointed out. The other thing I want to say is that what we do in neuroscience is very limited in many ways. One of which is that we look at what's common, statistically common, across many different individual brains, and in comparison to a control condition. So when we say the action word, action words are associated with distinct activity in the primary motor cortex, we are not saying that that's the only region that was engaged. By no means. What we're saying is that there were 30 people, and for each of them, these words elicited different patterns of activation, and they were very widespread, maybe across the whole brain with different levels of intensity. Now, when you average all those activations that were evoked in 30 people while they were reading action words, and then you average their patterns of activation when they were reading non-action words, and then you subtract both things, what you see is, hey, here's the difference. The thing that discriminated between the two word types is this pattern of activation here. But that is not to say that the words, when they were processed, in the very moment, they only activated that. Of course not. So a word, if you will allow my metaphor, it's like an invitation to. And that the door to that invitation is opened by your hand differently than it is opened by my hand and by anybody else's hand. One of the epitomes I find the most illuminating about the relationship between words and meaning, it is apocryphal as far as I know, although some people have attributed it to Firth, but it's words do not have meanings. Rather, meanings have words. And that's there's so much packed in that idea that actually we have very complex patterns of experience, feelings, remembrances, projections, introspections, imaginations, and then we try to find the words that best capture significant aspects of those things that are actually intransferable. So that's the way in which I think about these things. And what we capture in terms of brain dynamics, it's just the differential level of activation upon averaging what happened in the brains of a number of people for this condition versus this condition. That can never be tantamount to saying that action verbs reside there or only evoke activity here. That would be wrong. So I don't see much of a conflict between your wide experiential conception of what words could evoke in our heads and how that can be sculpted by our personal experience, and what you actually see when you look at the image of one brain processing one word. Because what I show you here and what neuroscience papers show you are the average of averages. And that is never what happens in the unicity and irreproducibility of the experience of what happened to you at this moment in time when you were looking at this work in your brain.
Okay, thank you.
Very good. We have very little time left, but there's still a few more unresolved points. Adolfo, why do you say, I understand, for me, an abstraction is something like democracy, justice, truth, etc. But why do you say that a headache or a stomach ache or anguish is abstract? There's nothing abstract. There's nothing could be more concrete than the referent of those words.
I'm not so sure that all the words you mentioned would fall within the same category. Canonically, within abstract words, there are different types of concepts that have been taxonomized in the literature: philosophical, mathematical, social, emotional, interceptive, and so on and so forth. Usually, words are abstract. It's not so much a dichotomical distinction between concrete and abstract words, but more of a continuum. Where abstract words, typically they have less consistent reference. So the reference of table, they tend to have some shared sensorimotor properties. They could be plastic, wooden, metal, whatever, larger. But with abstract words, you don't have such consistency in the sensorimotor properties of the reference. The reference also tend to be non-graspable by the senses. So you can see a chair, you can touch a chair, you could smell a chair, but can you touch anguish? Can you smell anguish? Can you throw anguish around? Can you chew on anguish? No, you cannot. So that removal from direct, immediate sensory motor experience is also one of the key determinants between concrete and abstract.
You don't think that having a toothache is a sensory experience?
Absolutely, yeah, yes, it is.
Well, why? What's the difference with is anguish different for you? I saw a difference with justice and democracy, because I don't know what democracy feels like, and I can't point at democracy. So that there's a question about the abstractness of the referent. But for everyone that you used, anguish and any other bodily state that feels like something to be in, it has just as concrete a referent as a chair. It's not visual, it's interoceptive, but it's a referent.
I beg to differ. I think that it is one thing to propose, and I think this would be right, to say that anguish has actual physical, visceral correlates. You can feel your intestines doing something. You can feel the sweat, right? Your pupils will dilate. But that is not, those are, if you will, signatures, correlates, aspects of anguish. Anguish goes beyond those physical manifestations. So I would absolutely stand by the claim that anguish is an abstract concept. Also in terms of the, there's another thing that discriminates between concrete and abstract concepts. If you ask a random selection of 1,000 people to tell you what a chair is like, to describe a chair, or if you show them chairs and you tell them, what is this called? There's going to be massive intersubjective agreement. But if you do the same thing with anguish, you will see that the responses are much more varied. And there's also the issue of visualization. Concrete concepts, they tend to be very directly, iconically or pictorically describable. You can draw a chair very simply and people will identify as such. Anguish does not lend itself to such primary sensory representations. So those are the lines along which I conceive of this dichotomy. I do not claim to be right. I do not purport to have the truth about this, but I just want to be explicit about the terms along which I conceive of this. And of course, this is a matter of debate.
Let's end this on a more ecumenical note. What you said about negation. Do you have other examples of syntactic reference or say syntactic functions besides negation? Because negation, which is positive or negative, is already connected to whatever it is that it's more positive, negative for. If it's movement, it's making the movement or not making the movement. If it's red, then it's red, not red or not red. So that's a special case. Another syntactic example.
There are two things I could mention. Certainly, the grounding of syntax is much less studied, but I'll be very brief here. One, in patients who have problems coordinating hierarchically organized sequences of movements, so do you find problems in processing hierarchically organized sequences of words. That is syntax in a nutshell. So there are syntactic deficits in people who have movement disorders, and you don't find those in people who with spared motor system networks and other types of brain compromise. The other thing is there's one study by friends from Spain who've shown that if you compare sentences with embedded constructions, sort of a hierarchical rank shift, and sentences in which you don't have embedded constructions, and you ask them to, after they process those sentences, to perform sequences of movement in which there's a pattern that is embedded within another pattern, or sequences in which there's no such embedding, you have a compatibility effect, such that you perform the sequence of embedded movements better if you process an embedded construction before than if you didn't. So that being said, it is absolutely true that the grounding of grammar is much less studied, and we are operating on more speculative than empirical terms when it comes to thinking about the grounding of grammar.
Okay, look, there's 1 minute left, and Jean-Guy had his hand up. If you can do it in 30 seconds, maybe Adolfo can answer in 30.
I've noticed that in your expertise, you were working with the humanities. I find your theory, your not your theory, but your results very interesting for people working in poetry, where precisely poetry connotes these different dimensions by the words. Having a poetic experience is not knowing about the reference mainly, but creating by the words these very complex internal fears, feeling, pleasure, and that. Do you have any connections with these people, or? Because I find the approach very rich for poetry, meaningful understanding.
Not in any formal or systematic sense of the term, but I'll say these two things. First, poets do what we study. Basically, a good poet knows exactly how to make your affective, motoric, visual systems tick with right word choices, syntactic choices, stylistic resources, and everything. And the second thing is that the reason why I became a scientist is because I failed as a poet. So I guess there's some continuity there.
With that, I want to thank you very much for your interesting and stimulating. Oh, Rushen, did you have one more? Rushen?
Yes, sorry, my micro. Just one last thing to catch up with you for the comment you just made with the study with the syntactic embedding hierarchical structure that affected their subject's performance on the sequencing of motor. Are you saying that your model extends beyond comprehension, meaning you actually are looking at how grammar, how the structure embedding or structure hierarchical structure of the grammar could have impact on motor performance?
Yes. The evidence
That's
is very
pretty. So your theory is pretty broad. So linguistic, not just at the semantic level. You're talking about syntactic complexity. When the syntactic complexity is involved, you're also expecting some motor involvement, consequences, or connections with that in the processing.
It could be motor or not. I mean, I'm talking about grounding phenomena, which I hope I've made the point that it's not just about the motor system. But yes, absolutely. Not only that, I mean, there are grounded phenomena for phonological perception. There are grounded phenomena for morphological compositionality. There are
Well,
grounded
that's-
phenomena at the level of pragmatics. So,
So
absolutely.
you're open to encompass all of these aspects. And, you know, in phonology, phonetics has some motor aspect in anyway. So
Yep.
those, but it's more at the abstract level. When you talk about morpho syntax, these are symbolic objects that we manipulate in the brain, which is internal. And if that has, you know, motor consequences, that's something big, because syntactically you have certain operations that you can make predictions about the movement, surface movements. You can have predictions about embedding, a level of embedding, and syntactic distancing with the agreement. And you would want to go that far to involve those kind of mental manipulations to make a connection with with actual motor performances?
Yes, but again, not just about the motor system. And in particular, I would take objection to the notions of symbolic and manipulation. Those are two things that I believe are just artifacts of certain theoretical persuasions. I don't think there's any reality or practical utility to those notions, but that's probably for another talk.
Have you never done long division in your head?
Oh, I can't go beyond 2 + 2. So
that's symbol manipulation. Anyway, I want to thank you. We've run out of time. You've managed to get several disciplines involved that are not always involved in this series of seminars, and that's very welcome. And I thank you very much. And I invite David Labrec and Victor, have a look at the recording will be available within a day. And especially on the question that was raised during the talk about push-pull and so on, you might want to communicate directly with Adolfo.
Thank you very much.
Thank you.
It was a treat, and congratulations on hosting this series. Very valuable, very, very interesting. Thrilled to have been a part of it. Thank you.
Thank you very much.